solutions, yes? All right, so we want to go through the sample test today. From start to finish, you are welcome to take off on your own and work on it on your own, but we're going to work through the whole thing together. All right, so to begin with, the first couple of things ask you to use your graphing calculator, so grab that if you would, please. All right, and so for these, we're just typing straight in. So we've got 2 and then to the, and again, remember anything I touch turns red. So 2 to the, you can see highlighted in red there. That's how I get up to my exponent if you're not sure. And then negative 1.4. All right, 2 different places that you have an E button on your calculator. There's one above ln. And that's the one that I'm going to use. So second ln, there's another one over the division symbol. But e to the negative 1.4. And then log of 1.8. When there's no base, we assume that's the common log, the base of 10. So I could just type in log of 1.8. And then they also wanted the natural log of 1.8. So natural log of 1.8. And then the last one, they wanted the log base 5 of 8. And we actually have 3 different ways that we can put that in our calculator. The fastest, easiest way is to do alpha and then window. And then you can see for my number 5, it may not be your number 5, but for my number 5, I have log base. And so when I choose that, then I can put in any base that I want to, and I can put in what I want it to take the log of, and it will do change of base for me. Now, if I don't have that button, or if I'm working on a scientific calculator or something like that, and I need to do change of base, remember that you're going to put the 8 in the top and the 5 in the bottom. And you can either use your log button or your natural log button, either one. So I'll do it both ways just so that you can see it. So first I'm going to use the common log. So I'm going to have the log of 8 over the log of 5. And you can see we get the exact same answer we did just a second ago. All right, and then same thing with ln. So again, you don't have to be able to do it all 3 ways. You just need to do whichever you like, because they all do the same thing and they all give you the exact same answer. Okay? So for numbers 1 through 5, you are just typing those straight in. Okay, so let's look at so we just did 1 through 5 on the calculator. So let's look at number 6. All right, so number 6 deals with compound interest, and so you've got to know your compound interest formula. So your compound interest formula is A, the amount you're trying to find, is equal to P, the principal, the amount that has been, that you're plugging in, that you're starting with. R is your rate as a decimal. N is the number of times that it's compounded. Now, what we mean by that is, like, if it's quarterly, it's compounded 4 times a year. If it's monthly, it's compounded 12 times a year. That's what that N is. And then T is just your time in years, okay? So for this one, it says your grandparents gave you $500 for graduation. So what's 500? That's your P, that's your principal, right? You invested at 5.5% interest. How do we write 5.5 as a decimal? 0.055, right? So there's our rate, all right? And then it says it's compounded quarterly. So how many times is that a year? 4. So we're going to put a 4 in for each of our n's. And then it says how much do you have after 4 years? So we're going to put a 4 in for our time as well, okay? Please make sure on your test that you give me your setup, this right here. Because if by chance you type it into your calculator wrong, I can just take off 1 point because I can see that you knew what you were doing. You just typed it in wrong. Okay. And I mean, obviously practice typing those in correctly so that you don't lose points on them. And I gave you just, a little screenshot there so that you could see that. But, all right, if it's compounded continuously, we have a totally different formula, right? If it's compounded continuously, we use the Pert formula, all right? And the Pert formula, what does P stand for? Principal, and R and T are still the same, still your rate and time, okay? So we use the same 500 for principal, we use the same 0.055 for the rate, and we use the same 4 for the time. And then again, plugging that into our calculator over here, the 500e to the 0.055 times 4. So again, give me your setup so that I can see if you missed something on that so that I can give you partial credit. All right? Questions about anything on that first page? All right, flip your page and let's look at graphing. All right, so it says for questions 8 through 12, use f of x is equal to 3 to the negative x minus 3. All right, so to begin with, before I start shifting or anything else, I want to just graph the base function. All right, so the base function would be 3 to the negative x. Okay, we had two types of exponential functions. We had an increasing and a decreasing. So for the way that I can tell the difference is if this is 3 to the positive x, it's going up. If it's 3 to the negative x, it's going down, right? They also had two landmarks. What were our two landmarks? Every exponential function has two landmarks. What are they? So we have a y-intercept at 1, and we have a horizontal asymptote at 0. All right? So I know what this graph looks like because I know I'm going to come down here and approach this asymptote. So now all I need to do is just plot 1 point over here on the left-hand side. And so I just picked -1. So when I plug -1 in, 3 to the negative 1, that'd be 3 to the positive 1, or 3. So that gave me this ordered pair right here, 1, 3. And now I have everything that I need to sketch my base graph. All right, then what is that -3 going to cause? Vertical shift. Yes, vertical shift of what? +3 or -3? -3. So we're going to shift down 3. So we're going to take that same graph that we had and move everything down 3. All right, so if your asymptote was at 0, if it comes down 3, where is it? -3. If your intercept was at 1 and it comes down 3, where is it? -2. And this point over here, -1, 3, bring it down 3, and you'll have -1, 0. All right? So then we can sketch our shifted graph. Okay, so now let's answer all the questions they want to know. All right, so what was your asymptote? And we're talking about the final graph here, right? What was our asymptote down here? -3, and we want to say y equals -3, not just -3, because -3 is a point, y equals -3 is a line. All right, then for 9, what's the y-intercept? Where did it cross the y-axis?
-2.
Right there at -2. Now, if for some reason you weren't comfortable with that, and you, by looking at the graph, and you wanted to find it, remember that you can always find it by plugging 0 in for x. And so sure enough, when we plug 0 in for x, we get -2 as well. But you can just look at the graph and see that. All right. Number 10, what's the x-intercept? So same idea. For the x-intercept, you can just look at the graph because we've got that point plotted. So what's our x-intercept? -1, but if by chance I didn't have that point plotted, remember that you can find the x-intercept by putting 0 in for y, okay? So if I put 0 in for y, I want to get this exponential by itself, so I'm going to add 3 to both sides. All right, so now I have an exponential equation and my bases are the same. So remember, when your bases are the same, that you can set your exponents equal to each other. So I'm going to set 1 equal to negative x and get x equals negative 1. And again, that's that same point that we saw on our graph. So either way, you can solve it algebraically or you can look at the graph, either one. All right, then for 11, we've already sketched the graph. And then for domain, for number 12, okay? So if we look at this green graph again, okay, if we look at it, what's it doing as it goes off to the right? Uh-huh. Okay, and what x values are we using? Infinity. All right, look at it as we go over here on the left-hand side. So as we go over here on the left-hand side, it keeps going and going and going and going, right? So what would that be? Negative infinity, right. So the domain of every exponential function is negative infinity to positive infinity. It doesn't matter if you shift it, reflect it, whatever you do to it, every exponential function is going to be all real numbers for its domain. Okay, then for 13 through 17, we wanted to graph our logarithm, all right? So remember, with the exponential, we've got the two landmarks. We've got the horizontal asymptote at 0 and the y-intercept at 1. Because exponentials and logarithmics are inverses, x and y switch places. So on the, one other thing. I just wanted to mention to you, there were two different types of exponential functions, right? Like we had 3 to the negative x and we had 3 to the positive x, right? So we only graphed 3 to the negative x, but what if this had been 3 to the positive x minus 3? What would that have looked like? What's the difference between the two? Yeah, whether it opens up or whether it opens down. So my original function, if it was 3 to the positive x, my original function would be up here, and then I would vertically shift it a negative 3, so it would come down here. And so these other things would still be the same. You know, we'd still have the same horizontal asymptote. We'd still have the same y-intercept. Our x-intercept would be on the other side. But I just wanted to make sure that you remembered what the positive one looked like as well, because the example was only the negative one. Okay, so anyway, back to what we were talking about with graphing our logarithm. We said that for the exponential function, we had two landmarks. We had a horizontal asymptote at 0. So on the logarithmic, x and y switch places, and we have a vertical asymptote at 0. On the exponential, we had the point 0, 1. So here we have the point 1, 0. All right, so I already know what this piece of my graph is going to look like, all right, because I know it's going to approach the asymptote. I just don't know how steep to make the part up here. And so I need to plug in a point. So if we have y equals log base 5 of x, I'm going to switch that over to its exponential form. And that's x is equal to 5 to the y. It's actually easier to plug in y values here than it is x values. So I put in 1 for y, and I got 5 for x. So there's that point right there, 5, 1. And so then I know how to graph my logarithmic function. So again, using my two landmarks and that 1 point. All right, now this one, they didn't want me to shift it or do anything else with it. So where is my asymptote? X equals 0, yes. All right, how about my y-intercept? Where did I cross the y-axis? Did I cross the y-axis? No, so that just means I don't have a y-intercept. All right, then for 15, where did I cross the x-axis?
1.
At 1, 0, that was one of my landmarks, right? And then sketching the graph, we've already done. And then domain. So if we look at our graph and we look at the domain, there are two different ways we could do this. First, I could look at my graph and I could say I'm going right up to 0, but not including it. And then I'm going off to positive infinity. So I could say from 0 to infinity. The other thing that we've been doing is we have been working with domain where we said you can't take the log of 0 or a negative number. So anytime they ask me to find domain, I'm just going to take whatever I was taking the log of and set it greater than 0. So what I was taking the log of was x. So I could just set x is greater than 0. So either way, look at the graph or use that domain law, either one, whichever you like better. All right, so questions about that second page with all the graphing things on it. All right, then let's solve some logarithms. Okay, so when we have a logarithm, what is the first thing we always want to do? Switch it to its exponential. Yes. So what would this be in exponential form? Yes, 4 to the x is equal to 1 over 64. All right, so now we want to get our bases the same. So we can set our exponents equal to each other. How can we write 64 with a base of 4? Well, 4 times 4 is 16 times 4 is 64. There it is right there. So I can rewrite 64 as 4 cubed. Now, how do I get it up to the top? Negative exponent, right. So now my bases are the same and I can set my exponents equal to each other. So I can say x is equal to -3. All right, look at the next one. So for the next one, there are a couple of different ways that I could go with this. So suggestions? What could you do with that 2 that's out in front? Make it an exponent. All right, so what do you do when you have a power raised to a power?
Multiply.
Multiply, so that would give me ln e to the 10th, right? Then we had a property that said ln and e do what to each other? Cancel out, so my answer is just 10. Now, another way you could have done that one is up here in the very beginning. Maybe you looked at this and you went, okay, ln e drops out. And so that would just give you 2 times 5, and that would also give you 10. Okay, so like we said, a couple of different ways that you could approach that one. All right, for the next one, they give me 2 logs and they ask me to simplify it. So if I have 2 logs that are being added, how can I simplify that? Combine them into one log that's being what? Multiplied, yes. So I'm going to combine them into one log that's being multiplied. All right, so now that's a whole lot easier to work with. So now we've got the log base 4 is 64. What can we do with that?
Set it equal to x.
Yes, set it equal to x, and that way we can switch it to its exponential form, right? Okay, so its exponential form would be 4 to the x equals 64. So 4 to the x equals 64. All right, and then we're back to what we had done just a moment ago. 64 is the same thing as 4 cubed. And then once my bases are the same, I can set my exponents equal. All right, look at this next one. What happens with e and ln?
Cancel out.
They cancel out. So if you take the natural log of e, or if you take e and raise it to the ln, either one, they cancel out. And so you can see our answer there would just be x to the 4th. All right, so in number 20, we condensed 2 logs into one. We want to do the opposite now. For number 22, we want to expand. So I'm going to take one log and I'm going to expand it out into separate logs. All right, so if I have 2 things that are being divided, how do I write them as separate logs? Subtract, right. So I'm going to have the log base 3 of x to the 4th minus the log base 3 of y. All right, then what can I do with the exponent on log base 3 of x to the 4th? Move it out in front, right. So that would be its expanded form. Nothing else that we can do with that. All right, then 23, they want us to do the exact opposite. For 23, it says take the 2 separate logs and combine them into one. All right, so if you have that 5 out in front, what can we do with it? Make it an exponent, and then 2 logs being added, we combine into one log, multiplying, right. So we would put those together and we would multiply the 8z to the 5th. All right, domain of a logarithm. What can you take the log of? What can you not take the log of? Can't take the log of a negative number or 0, right? You can only take the log of positive numbers. So we said when you're doing domain for a log, you're always going to take whatever you're taking the log of and set it greater than 0. So whatever you're taking the log of and set it greater than 0. All right, so x plus 5 is greater than 0. How are we going to get x by itself? Subtract the 5. So we'll have x is greater than negative 5. And of course, there's our interval notation for that as well. All right, questions on that page? All right, and then our last page, we are solving a bunch of different types of equations here. So,
Ms. Whitmore?
yes, ma'am?
I need to see Magnus Anderson, please.
Okay.
Thank you.
All right, so for this one, we've already done one just like this. So ideas, what do we need to do with this? Do what? Yeah, the base is the same, yes. So 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, all right? So we can rewrite 243 as 3 to the 5th. Now, how do we get it up to the top? How do we move it from the denominator up to the numerator? Negative exponent, right. So we had 3 to the 5th in the denominator. To move it up to the top, it's going to be 3 to the negative 5th. All right, so now my bases are the same. So what can I do with my exponents? Set them equal to each other, yes. All right, look at the next one. For the next one, what do we need to do first? Yeah, we got to get rid of that 2. That anytime that you're working with exponential or logarithmic, you always want to get it alone first. So I'm going to divide both sides by 2. All right, now, how do I get rid of that exponential? ln, yeah, I'm going to insert a log on both sides with the same base as my exponential. So we had a base of e that we were trying to get rid of. So we're going to put in a log with that same base. We're going to put in log base e. So log base e is ln. And of course, what you do to one side, you have to do to the other side. Okay, so what happens to the ln e? Cancels out. So I'm only left with 3x minus 2 on the left-hand side. And then is equal to ln 40. All right, so now how do we get x by itself? Add 2. And divide by 3. Yes. So if you're on a portion of the test where you have your calculator and it says to give a decimal as your answer, we can plug this in. If not, if you're on a portion where you don't have a calculator and you're solving this, because remember there's part with and part without for this test, then I would want to leave it like this. Okay? All right, 27. What do we do with a logarithm? What's the first thing we do to it? Put it exponential. So what would that be in exponential form? What would it be in exponential form?
17.
Yes, 7 to the 3 is equal to x, all right? So then we're just doing 7 cubed. So 7 times 7 is 49 times 7 is the 343. All right, and then for the next one, we have another log. So what do you want to do to it first? Put it in exponential form. So what's that going to be in exponential form? Perfect. X to the 5/3 is equal to 32. All right, so how do we get rid of that 5/3? Yeah, reciprocal. We're going to raise it to its reciprocal. We're going to raise it to the 3/5. So I need to get x by itself. So I got to get rid of this 5/3. And the way that I do that is I raise it to its reciprocal. Because what's 5/3 times 3/5? 1. So that would give me x to the 1 on the left-hand side, which is what we want, right? We're trying to get x by itself. All right, what you do to one side, you have to do to the other side, though. And so over here on the other side, we're going to have 32 to the 3/5. So remember that the top number is your exponent and the bottom number is your index. So we're going to have the 5th root of 32 cubed. Now, it's a whole lot easier to do the root first. So what's the fifth root of 32?
2.
2. So then we would just have 2 cubed, and 2 cubed would give us 8. So definitely want to do the root there first and then raise it to the exponent. All right. Then for 29. For 29, we have another logarithm. So what do we do with every log? Exponential, right. So what's the base on this one? E, yes, not 10. Okay, there's no base written, but remember that ln means log base e. All right, so let's rewrite that as log base e of x plus 2 is equal to 0. Now we can switch it to its exponential form a little more easily. We can see it a little easier. So we're going to say e to the 0 equals x plus 2. All right, what's e to the 0? What's anything to the 0 other than 0? 1. So we're going to get 1 is equal to x plus 2. And subtract 2 from both sides. And we get negative 1. Now, when I get a negative answer for a logarithm, it makes me nervous. Because remember, you can't take the log of a negative number. And we have to check for those extraneous roots. So I take that negative 1 and I put it back up here. And I'll have ln negative 1 plus 2. So that's still ln 1. I'm good. I'm not taking the log of a negative number. So that one's okay. All right, look at the next one. So for 30, we have an exponential function again. So what do I want to do to get rid of the exponent? What undoes an exponential? A log, So I want to put in a log on both sides. Specifically, I want to put in a log with a base of what? 3, right. I want to put in the log with the same base as the exponential, all right? So I'm going to insert a log base 3 on both sides. Now, on the left-hand side, what happens to the log base 3 of 3? It cancels out, right? And that would leave me with just x plus 2 on that left-hand side. Then how do I get x by itself? Subtract 2. So again, we would leave our answer this way unless we had a calculator to plug it into. All right, now when we were solving our logarithmic equations, I mentioned to you that there was one that solved differently from all the rest. And the way that you could spot that was because you would have more than one log. This is the only one, number 31, this is the only one that has more than one log, right? It has 3 of them. So let's start on the left-hand side first. If you have 2 logs that are being added, you can combine that into one single log that's being what? Multiplied, right. So let's combine that into one single log that's being multiplied. So all we did was took the 7 minus x and the 3x plus 5, and we're combining that into one log that's being multiplied. All right, so let's FOIL that out. So we're going to have 7 times 3x is 21x. 7 times 5 is 35. Negative x times 3x is negative 3x squared. And negative x times 5 is negative 5x. We could do a little bit of combining there, and I also put mine in descending power order so it looked more like a quadratic. So I did negative 3x squared, and then the 21x minus 5x gave us 16x, and then 35. All right, we had a property that said if ln x equals ln y, what has to be true? X equals y, yes. So if the natural log of one quantity is equal to the natural log of another quantity, then we can say those two quantities have to equal each other. All right, so now I have a quadratic that I need to solve. With a quadratic, we always set it equal to 0 first. So let's go ahead and subtract the 24x to the other side. So when I do that, 16x minus 24x gives me a negative 8x. I do not like to factor when my leading coefficient is negative. It just makes it so much harder for me. So I chose to multiply this entire thing by a negative 1 just to make it easier to factor. So positive 3x squared, positive 8x, and negative 35. That's why every one of those signs changed. And then, of course, we just factor and set each of those factors equal to 0. Now, remember we talked about you have to check your solutions and make sure that you don't end up taking the log of a negative number. Look at that -5 right there. If I put -5 in over here where it's 24 times -5, that's going to be the natural log of a negative number, right? So I can't take the log of a negative number. So that is an extraneous root. It is not an actual solution. I toss it. All right, last one, 32. For 32, we have ln 5x is equal to 0. So what do we do with every log? Make it an exponential. What's the base? Ln's the same thing as log base what? E, right. So I can rewrite ln as log base e. So now let's switch that to its exponential form. So what is it in its exponential form? E to the 0 equals 5x, yes. So if e to the 0 is equal to 5x, what's e to the 0? 1. So 1 equals 5x. Divide both sides by 5, and we'll get 1/5. Okay? All right. So as we have said before, if it's not on this sample test, it's not on your test. Your test looks just like this with different numbers in it, all right? If you look at your test review sheet, on the bottom of your test review sheet, it tells you your test is in 2 parts, 1 part with a graphing calculator and 1 part without. The things that we did at the beginning with the graphing calculator, I even put the screenshots there in your sample test. Those would be the things that would be on the calculator page. And then the remainder, you would not need a calculator, and that's why we've been leaving all of our answers in these funny forms like, you know, the -2 plus the log base 3 of 21 and the ln 40 plus 2 over 3. That's why we're leaving them that way. You won't need to worry about typing those in and simplifying those, okay? Also, don't forget, review homework quiz is due in WebAssign.